Welcome to SystemVue. This demonstration will look at how the Model Configurations tab can be used to easily control model polymorphism for verification using the base SystemVue platform. We'll also show how the Model Configurations tab is integrated with the C++ code generation and Visual Studio. SystemVue supports a number of different representations for models. And in a model-based design flow, the task is to go from algorithm to implementation and compare the implementations so that you preserve the original intent of each block as it moves to a hardware instantiation. In SystemVue, moving between these models is relatively easy. However, when you have large sets of models, all fixed point, or all M-code, or all graphical subnetworks, it's helpful to have a way to bank switch between sets of models. The new Model Configurations tab on each schematic allows you to set up named configurations that permits you to switch these models directly from the analysis controller at the top level. In this demonstration, we'll look at switching between three model representations very quickly, and then walk you through the process of generating C++ code, compiling it, and bringing it in as a fourth model. Hopefully this will give you a feel not only for the new Configurations tab, but also the polymorphic and modeling flow within SystemVue. So let's get started. The example we're going to use today is an extremely simple custom modulation format that simply has a modulator and a demodulator. From this we can put bits in, we can get the bits out, we can look at amplitude states and constellations, and very quickly use a simple example just to demonstrate the process. I want to focus on this polymorphic modulator. And this one schematic symbol actually has three possible simulation models behind it. If we double click on this, we can see that they have been loaded as the model tab. So in a SystemVue polymorphic situation, I can switch to different models and I can see the parameters change for each of the models. I can do this manually on a block by block basis and re-simulate. What's more difficult, however, is if I have lots of blocks, I have to switch them all at once. How do I do that? Well, the answer is the new Model Configurations tab. I can come to the tab here and say Add Configurations, and we're going to say mapper floating point, and I'm going to add the part. The part was our special modulator. You can see that I can choose any of the three models associated with that. We'll go with the native mapper. Let's add another configuration and say mapper network. Add the part. For this part, we'll stick with the subnetwork. And finally, we'll add a model configuration for the math language version of this particular part. We'll change to the math language. So now I have three configurations. And what's nice is that it's now controllable directly from the analysis controller. So if I say floating, I get one answer. If I say network, I get one answer. Here's the network, just so you've seen it. And if I say math language, I get a different result. So let's go in and investigate what this is about. Let's zoom in a bit. We see that we have quite a bit of errors. If I double click on this and go to the math language, I can see that I have a sign error. When I go back up to the top level and re-simulate, it's now fine. One hint for verification is if you have noise sources, you can set them to have repeatable random sequences, which turns off the randomness so that you get the same result every time. And you want to make sure that you do that so that you keep getting exact results. Okay, at this point, I'm going to take that graphical subnetwork and generate a C++ project in Microsoft Visual Studio, compile it and bring it back in, and give it a named configuration so you see the modeling process in action. Okay, the first step is I will add a C++ code generator. And if you look at the defaults, we're going to say network, add part, get our modulator, do the code generation in a specific directory, we have some choices of a standalone model or a source code, and I'm going to check the box to automatically add to my part list. So let's hit generate. And it's popped up Microsoft Visual Studio Express Edition. Let's go back to the original SystemVue environment and look at our polymorphic model. And now I have another model here. The compiler has automatically added it to my model list. And I can go into configurations and add a new configuration for mapper C++ and add my new C++ part and come to the top level and verify it. So SystemVue generated the model, compiled it, and brought it back in. What we can do is go to Visual Studio and actually look, if we want, at the source code for this block, say build solution, and it succeeded. So we've rebuilt the DLL. If we go into the subdirectory, and if I drag and drop the DLL onto SystemVue, you can actually see that it's added the new library with the block. If I want to place the block, I can. But that wasn't necessary. It had already added it to the polymorphic model. To control the automatic behavior, you can go to Library Options, Code Generation, and start Visual Studio and automatically compile each time if you choose. This example is available in the model building directory of the example tree. If you'd like to see other example videos like this, go to www.agilent.com/find/esoft-systemvue-videos. And good luck!